math classes up towards as we get higher. So like next year in pre-calc, if you take it, you have to be able to factor because it's such a big part of algebra. Similarly, calculus, you have to be able to factor. So we're hitting it hard now. We're going to extend out a little tiny bit. We're looking at two different applications of factoring today, and we're going to hit both of them. I'm going to give you an option. There's two things that we're going to look at. Finding an equation. So before you write it down, let's commit to which one we're doing first because they're not intimately linked. Finding equation of a parabola, there's one. We've done that with vertex form, and that's all that we've done it with. Or we can look at inequalities, quadratic inequality. You want to start with inequality? Okay, we'll start with quadratic inequalities, and then we'll finish on that finding the equation part. So we are still in 2.3, and we're just going to sneak ahead. Quadratic inequality. Now, I don't love the way that the book presents these for the very first time. Again, this is still just the conclusion of Chapter 2, Section 3. When we're looking at quadratic inequalities, there's a few different ways that we can view these. Now, do you guys love graphing functions? Like, hopefully it's not terrible because we saw that there's some shortcut stuff that we can do. But if you're given the option of solving something graphing or not graphing, you're probably going to go not graphing. Okay, good. So check this out. We're going to make a couple little things. First off, we're going to recall something. And that looks like it says, there we go, recall. And I want you guys to help me with this. This is a key features of functions from like 1.1. It's been a while since we addressed this even a little bit. I'm going to sketch a graph of a parabola. And I'm going to draw it here. So here's a wonderful parabola. And then I'm going to say that here's, at that first x-intercept, here's A and B. Now, don't really care what the numbers are. We're just doing it in general right now. If I asked, and I'm going to label this so it gets a little bit more clear, and I'll quit walking because don't pause. Yes. Okay. If we label this function f of x, so here's the graph of a function f. Okay. If I want to know just from this, when is, and we'll say dot, 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 and just a few little questions about this. The first one, I'll just put an asterisk. F of x positive. Is there another way that we might word that so it feels a little bit more natural? Or let me change that. Rather than saying when is f of x positive, which that's what I'm asking, and can you guys tell me on that graph when it is positive?
Above A and B.
So above A and B. What do you mean above it?
Above it.
So where the graph is above it? Okay. Can you give me ranges on the, or values, intervals, if you will, on the x-axis for when it's positive?
1, 1.
Why 1? We have no numbers.
Oh.
Maybe. Like, I don't know the function. Maybe, realistically.
From whatever number B is to infinity.
So B to infinity. So here to the right is a graph always above the x-axis.
Yeah.
Okay?
A
And then
to the
A
left.
to the left. And we'll clean that up here in a second. But do you guys agree that where Declan just pointed out, and I'm going to shade it, you don't have to shade yours, he said over here it's positive and over here it's positive. Do you guys agree with that?
Yes.
Okay, Kian, you look like maybe not. Why?
The X and A is.
So, right, but what are we asking about? When is what positive? The function. So is it, if it's above the x-axis, it is called positive. You were right with that. Now, if I wanted that as an inequality instead, because this is just a statement, could we write a synonym or the same thing just with inequality stuff? What does it mean to be a positive value? It must be greater than what? 0. Are these the same statement? Like, they're obviously different phrases, but these are the same meaning. I'm going to just say here equivalent. Okay. Now, when Declan answered, he said to the left of A and to the right of B. I agree with it. I want to make sure we can clean up a little bit of the notation stuff because I had some people from first hour not quite understand and they didn't say it when we wrote it. If I write this, when is x positive or f of x positive? I think that this is true for any x in the interval or in the set from negative infinity to A. That's all of this. Anywhere on this side of it, my graph would be above the x-axis. Okay, what does this symbol right here mean? Okay, so it does. It kind of looks like a euro symbol. We're going to say x in the interval. In the setup is what it literally means, but we can think about an interval here. And are we all okay with the negative infinity to a?
Yeah.
That's a wrong way to ask a question. Good, I'm glad. Anybody not quite get what I mean by negative infinity to a? Awesome, thank you for telling me. Okay, if we take a vertical line, and you don't have to draw this, we'll just make sure that we hit it here. If I pick up this line, if I go to the left of a, does it cross my function? And even if I went over here, it doesn't, like, it looks like it doesn't, but I know that this parabola keeps going like this forever, and it will eventually. That's all we're looking at. So in the interval from negative infinity to a, is there anywhere else that is positive or above the axis? You say no, but I don't believe.
Wait, what do you mean?
Where else is it above? So like here it's above, and I think here, what's this interval? This is from B to where?
Infinity.
And then I left an awkward gap in there. How do I tie these two together?
Plus.
Not plus.
Equals.
Are you guessing?
Yeah.
Union. Yep. Now, I can show you a sweet message that I got from Miss V that covers this stuff, which is odd that it came from Miss V, but that's okay. Not the math, just a symbol. Now, this is x is in the interval, and I'm just going to leave it there, from negative infinity to a and b to infinity. Where is it negative?
A to B.
Okay, so here's why I want to really stress this notation. If I ask the same question just on the other side, I said when is, and we'll switch to green. If I said when is f of x negative or less than 0, Declan correctly tells me from a to b. Everybody agree with that? Here's my issue. If I just write this, what does it really look like I've written?
The x-intercepts.
So maybe in my, so like there's, and this is subjective, like I think that you're right, maybe that's how you view them. That looks like a point to me though. X comma y is what it looks like, even though it's AB. If we put this little symbol, x is in the interval or in the set, I no longer have to worry about is it an ordered pair or not. Now, your book will do this slightly differently. If you like these symbols in interval, which is what people preferred seemingly in throughout chapter 1, we'll stick with interval, but maybe the inequalities make more sense. Okay, notation-wise, just want to make sure we got it. This just means above and below. Now, couple quick checks. I don't know the value, but tell me right here, is my function positive or negative?
Positive.
So notice, Jade, because I think I know what you're answering, and I think it's the same thing that somebody else was answering earlier. The x value is negative, but not what I'm asking. What's the value of my function? Positive some number, right? I don't know what the y value is, but it's positive. What is it down here? Don't know the number, but I know, guarantee that it's... If I went from positive to negative, what did I have to cross? Has to be the x-axis. The y-axis wouldn't change the sign there. Okay. Can we all agree that if a function changes signs, it happens at the x-intercept? There's no other way for this function to change signs. It has to cross over the axis, right? To go from positive to negative or vice versa. Cool. Okay, we're going to use that. Now, if I scroll down just so we can't see it, and I say, where can a function change from being positive to negative? How do you answer it? Where's the only place that a quadratic function, like we're dealing with, can change from positive to negative? X-intercepts. I want everybody to make sure we have it. There's not very many times that I do this, but I want everybody to answer that question. When can a function change signs? When, at the x-intercepts, right? So we're going to try it again. When can a function change signs? The x-intercepts. That's the only place it could happen. Y'all, I appreciate that you're studying. I didn't mean to startle you. I appreciate that you're studying there, but I do think that you would benefit more overall by paying attention here too. Okay. Only at the x-intercepts. Now we're going to use that to just immediately jump in and knock out some examples. So we're going to find some inequalities, and I'm going to give you guys some homework tonight as well. I think I gave you the evens. I'm pretty sure. Let's check this out. I want to know when is f of x positive. And I'm going to write positive out. I would write greater than 0 if I was actually doing the problem normally, but I'm trying to use the same language as your text. So here we go. That's all that we're dealing with. On our first one, we are given this lovely function, and let's say it is x squared plus, y or f of x equals x squared plus 9x plus 18. Okay. Make sure you get this written down. Okay. There's several ways we do this problem. We could go all out, graph the actual whole quadratic, the parabola, put it on a page, and try to find it. But if you don't want to do that and you'd rather do stuff faster without having to graph, let's try something else. Where can that thing change from being positive to negative or vice versa? So we're going to try that again. When can a function change signs? At the x-intercepts. Give me another word for x-intercept.
X-axis.
So it's at the x-axis. It's where it intercepts the x-axis. But there's three more terms that we're after. X-intercept. Root. Zero. Starts with S and ends with olution. Solution. All right. Cool. So as we check this out, before committing to graphing it, if we could find the zeros, I know where it changes signs. Do we agree with that? So if we're looking at this problem, let's do that. You don't have to write all that down, but let's find the places that it could change from positive to negative or vice versa. Find the zeros. Okay. When I find the zeros, it's when I put what in for the y or f of x value? 0. So I'll write that. 0 equals, and then help me factor here. What's always the first thing we run through? Is there a GCF?
Yeah.
You say yes. Why yes? Just out of curiosity. Desi. Okay, that's fair. Okay. There's no GCF. And again, if they don't all have x and that's a 1, guaranteed there won't be one. Okay. Is it a binomial?
No.
No. Trinomial. Yeah. Do you guys know the square root of the first one? 1x. I prefer x just for the record instead of 1x. They're both correct, but 1x is not as natural. What's the square root of 18?
4.5.
I don't think so. I like the thought. I don't know, right? I'm not sure. Okay, so bummer. It's not a perfect square. Leading coefficient's 1 though. Now, good thing we have that up on the board. I'm going to multiply here, and I'll write the whole thing again. X squared plus 9x plus 18. I'm going to multiply which two terms? Okay, 1 times 18 is 18. I need factors of 18 that add up to what? 9. So let's see, 1 and 18, 2 and 9. 3 and 6. 2 and 7 doesn't work, Jade, because that gives us 14. It has to be 18. So it wasn't 1 and 18, it wasn't 2 and 9, but I do think that it will work with 3 and 6. Before you just keep kicking forward, I want to really highlight that shortcut from the bell ringer example. This grouping process, it will always work. Okay, Deck, I'm going to save a ton of time.
What?
We're going to see this shortcut so we can save time with it. Grouping will always work, but I want you to notice something. We had a leading coefficient of 1 on the bell ringer today, right? Yeah. And we found these magic numbers. Check out what happened. Here's x and a magic number that we had, the plus 39. X and a negative 27. There's my two magic numbers. If the leading coefficient, this number in front of the x squared is a 1, we can skip over it all. We just found our two magic numbers, means that without a whole lot of thought, if you want to group it, you can. What was one of my magic numbers?
X plus 3.
So plus 3 or positive 3, there's my factor, x magic number, plus 3. And the other one was what magic number?
6.
3 and positive or negative 6? Positive 6. We can skip over all the grouping every time that the leading coefficient is 1 and we find these numbers. I would encourage you to do that because it saves a ton of time. If you don't like it and you don't believe me, that's okay. You can group every time. It'll still work. This is faster. Can you tell me the values of x?
Negative 3, negative 6.
So if we set this one equal to 0, it's a negative 3. And if we set this one equal to 0, it's negative 6. Have I lost anybody in here? The only thing, and just in case you need it, and people aren't always vocal, and I get it because I was also not very vocal. When I'm asking that question, when people are answering it really quickly, they're solving these equations in their head. And they're just saying, oh, okay, well, this is x equals -3, because we'll just subtract a 3 from both sides. And this equation, x plus 6 equals 0, subtract a 6 from both sides, and we get -6. I think everybody in here can probably do that mental math, but if you need to scratch work, please show it. Okay, I'm going to ask, not done with that, I'm going to ask this question that we've already asked. When can a function change signs? And what do we just find? The x-intercepts, right? Now, for this, if you don't want to graph the whole parabola, we don't have to. I'm really only asking when is the value of it positive. Step 2, we're going to switch gears here. I'm going to find some places to check on the x-axis. And specifically, I'm going to make a number line, and there's only going to be 2 numbers on this number line. They're going to be our roots, our zeros, our x-intercepts, our solutions. That's it. We're going to put these on a number line. Now, there are some there's some things here that are going to make this faster, but there's a reason we're doing the number line, because I know that we're going to build up bigger functions in these. Okay, here's a number line. And we're going to be checking the function f of x, right? That's what we're dealing with. I'm going to put f of x right here to make sure that I can keep track of what it is I'm checking. What's one of my 2 zeros, David? What are the 2 zeros that we found on step 1?
X
Equals what?
x squared.
Go all the way down. These are my factors.
Oh.
And from the factors, we set it equal to 0, and we get our roots, our zeros. -3 and -6, right? Okay, on a number line, what's further left? Okay, I'm going to put -6 to the left, and I'm going to put -3 to the right. I don't really care where they are. There's no scale. I'm not going to include any other numbers. Okay, these are my number line with the roots, and then I'm going to put a little comment underneath, and we could have done it here. Maybe we'll put the comment. I've taken all the real numbers just now, that number line, and cut it into how many pieces? I see 3. I see this piece, and don't shade yours, but I see this piece here. I see this piece here. And then I see this piece here. These are intervals where my function will be one sign only. Now, remember, if we have a function, it can only change signs. Where? So if I checked something in here, if it were negative, it would be negative at every value in between. If it were positive over here, it'd be positive here and positive here. It has to be. Okay, as we look at this, we're going to do it the full way out. I'm going to say, there it is, make the number line with the roots. And then I'm going to leave some space here because I'll put it here. Check. What? I know how to spell. Check f of, I'm going to say number in each interval. Now, there are some shortcuts that are kind of lurking here, and you'll probably notice some of them, but I would caution you to not just 100% commit to using the shortcut, because eventually we're going to deal with uglier things that maybe the same shortcut doesn't exist. Okay, 3 intervals. Can you give me something in the most right interval?
Negative.
So it has to be between -3 and infinity. I'm going to plug it into my function, preferably the easiest number.
0.
0. Do we all agree that 0 would be in this side? So check it out. I'm going to check f of a number in that interval. So if we're doing 0, it's in this one. I'm going to try to evaluate f of 0. Now, I know it seems convoluted, but I'll show you the alternative, and they're like, this is beneficial. We're going slow through it now. It won't take this long. This is a version of f of x, right? Is this also a version of f of x just factored? So if I were to plug in 0, I could do it here or here. Which one's easier to plug in 0? You think so? 0 plus 3 is 3. 0 plus 6 is 6. 3 times 6 is 18. So that's not terrible, but check it out. What's 0 plus 0 plus 18?
18.
I think it was easier on that one, but it's maybe not. Okay, here's the weird part about these. Do we all agree it's 18? Do we all agree that it seems silly to write, but it's positive 18? Here's the deal. I don't really care about the number. I just care that it was what sort of 18?
Positive.
I know that this function is positive everywhere from -3 to infinity. If it worked for 0, it would do the same thing for 2 because it only changes once it gets to an x-intercept. Okay, pick something in here. -4 is a good choice. If I were to do f of -4, am I going to plug it in to option A or option B, do you think?
B.
B is way easier. Now, you're going to get the same answer on both of them. This is just the factored form of this expression. This one's easy. If I plug in -4, it'd be -4 plus 3. And we'll write equals -1 times -4 plus 6.
2.
And -1 times 2 is?
-2.
So I don't even care about the 2, but it's what 2? My function is negative everywhere between -6 and -3. I'm getting the number and just taking the sign and putting it up here. Okay, without calculating it, any guess here? You think it's negative again? I think it'll probably be positive.
Positive, yes.
I don't want to tell you that it's always this way. With quadratics, it will. Now, what I want you to be aware of, and it's not what we're doing yet, but quadratics do work this way, right? If there's 2 roots, it's going to be the same on the ends. But eventually, we're going to do functions that do stuff like this. And just because there's an x-intercept doesn't mean it changed sign. So I would always encourage to be able to check it. I think it will be positive. Give me a number that we could try with to confirm that. -10, sure. If I tried this one and I checked f of -10, I'm going to plug it into here again. That would be -7 times -4, which is a what? Positive 28. And notice it was positive. You guys were right. Okay. All of this will go much faster when we don't have to talk about the logic behind it. I really want to stress that. The original question is, when is f what? Positive. Are there places where f of x is positive? Okay, help me out here. We're going to do it 2 ways. We're going to write it with interval notation, and we're going to see maybe there's a different way you could write it. Okay, so interval. We are saying, okay, answer. Here it is. X is positive if x is in the interval. How do you express this whole set between -6 and who knows? What's that interval? Negative infinity to where? Okay, I'm going to make a mistake. You can write all the way up to here, and you're good with, but I want you to tell me why I'm wrong. Why is the bracket wrong, Jade? So why not? Why wouldn't I include it?
Because
6 is part of the negative.
Is it? Where did we get -6 to put on our number line?
6 in.
6 is in the x.
Let's see what it gets.
It's a 0. Is 0 positive? Is 0 negative? So we don't include it. If this were or equal to, we would. Okay, so we don't include it. I'm good with that. Is there anywhere else that's positive? Negative infinity to -6 says start here and go all the way to here. And you don't have to graph it. This is just me thinking it out. It's negative here, right? So where does it go back to being positive? -3 to infinity. And Jade, I see why you would want to say negative. You said 4, right?
No, I'm good
Like,
with -2.
you were probably thinking -2, but do you still see why that's not right? Because we can get really, really close. How do I tie these together? Union. Okay. If you hate this notation, I get it. That's okay. Like, you're allowed to hate stuff. Doesn't bother me. If you don't like this, there's an alternative. We saw set builder early on in the year. We haven't used it a whole lot, but maybe it's nicer here. This is a curly bracket. It's this guy. We're just looking at 2 ways to write the same thing. A curly bracket. We could think of this exact same answer as the set of all x values, because that's what we're using, such that, and we just use a vertical bar. Is there a way to write this inequality? Is this less than 6 or -6 or greater than? X is less than -6, and, I'm sorry. What else must be true? X must be greater than what number? -3. These 2 answers mean the exact same thing. These are synonyms, kind of, through notation stuff. Which one do you prefer? The interval, where I want to really stress that if we're doing it, we're going to include this every time, or do you prefer the set builder?
The first one.
Okay, here's the deal. I don't care which one you use. If you use the first one, you have to make sure you have x in the set of. If you use the second one, the set of x such that. We need to be really specific with what we're talking about. Okay, does this seem doable?
Yeah.
Now, just to check, the alternative, and I'm not going to make us graph it all together, but we will go ahead and put it up, not YouTube, weird muscle memory. The graph was x squared plus 9x plus 18. So check it out. F of x equals x squared plus 9x plus 18. Here's the parabola. We could graph it, and we've done graphs of like these. Negative b over 2a, we do all that good stuff. But if I take off the y's, the entire y-axis, notice I still have a number line. Was it indeed negative between negative 6 and negative 3?
Yeah.
All these points are below the x-axis. Was it positive out here and out here? We can answer this question without the graph of the parabola. We've really, truly only graphed just the x-axis. We don't need the whole parabola to answer this question. Okay, another one, but I want you guys to try one together. Do you want to do one more as a whole class first with way less talking?
Together.
Okay, so let's check it out. This time, I'm going to write it much more mathy. All right, on B, let's see here. I want to know, when is it true that, here we go, x squared minus 5x, x squared minus 5x. I want to know, when is this less than negative 24? And I know that it changes the way the directions look. I changed the problem without having to name a new example. This is less than negative 24 this time. Does it feel like a different problem?
Yeah.
Okay, negative 24 is unique because we don't have a negative 24 product property. But we do have a something else product property. It's not the 24 product property. 0. I want this to be a 0 because this doesn't mean anything to me. Can I add 24 to both sides? When I do that, notice how much easier this question becomes, even though it's the same. X squared minus 5x will add 24 to both sides. Plus 24 is now less than what? This is just another way of asking, when is f of x, what does it mean to be less than 0? You guys all agree? When is it negative? That's all this is asking. Now, we changed the direction. Instead of saying positive, I'm asking for the negative, but nothing else is going to change about this problem. It changes from being positive to negative at its what's?
X-intercepts.
Give me another word for it. But I agree. You're right. X-intercept solution, root or 0. Okay, can we find the zeros of this function?
Yeah.
So to find this, I'm just going to replace this. I'm going to rewrite this exact expression, but I'm going to use equals instead. X squared minus 5x plus 24. And I want to know, when is it equal to 0? Because those are the numbers that I care about. That's where it could change. And now we get to solve this using everyone's favorite F word.
Factor.
It is factor. Yep.
Factor. 3 and 8.
Deck is quick. You're not quite right.
Negative 3 and 8.
So,
That if you
and you're good now, Declan, just so you know. But these are 24, right? There's no GCF. It's not a binomial. The leading coefficient is 1. I need factors of positive 24 that add up to a negative 5. Ooh, maybe you're not right, Deck.
Oh, negative 5?
Has to be a negative 5. Say it again.
Positive 3 and 8.
Those add up to 11.
Positive 3 and 8.
That multiplies to be what? That multiplies to be negative 4, doesn't it? So here's the issue. There's a typo. I have a typo. I'm going to do two things. And I'm so sorry if you have pen. I'm going to make this a plus so this problem works. Because right now we can't factor this. And we haven't even talked about how to factor it. You might disagree with me. Let's check.
What do you mean you can't factor?
All right, sorry about that. I just had a typo. All right, that does change stuff quite a bit. Now we have negative 24. And now it'll work. I need two things that multiply to be a negative 24, but they add up to a what? Negative 5. Is it 1 and 24?
No.
Is it 2 and 12?
No.
3 and 8?
Yeah.
Ooh, 3 and 8. Which one needs to be negative?
3.
Are you
8.
8. Okay, pause. Once we get here, what's our leading coefficient? 1. There's a 1 right here. The leading coefficient is right there. Why do I ask that? Not rhetorical. If you guys need to chat, I'm cool with it. But why do I put so much focus on whether the leading coefficient is 1 or not? There's a shortcut. Can I get right to my factors here? X So you give me the roots. Give me the factors first.
X plus 3.
Plus 3. Notice a positive 3. And the other one is x, and what's the other magic number? Minus 8. Now those are still equal to 0, right? We don't leave it behind. What are the roots then? The zeros, the solutions, however you want to word it. X equals?
3 and 8.
Kian, do you second that? What, because why?
I was saying, yeah, I didn't say.
I didn't catch any of that. I'm sorry. Why?
Wait, is it disagree or agree?
Second would be agree.
Oh yeah, nice.
You do agree with it? Okay. What do I do with these numbers?
Put them on the number line.
Put them on a number line. Boom. And we're going to see that this is super quick. What's further left here?
The negative number.
Okay, -3 and 8. Now, because we know that this is going to happen every time, I have no objection to using a little shortcut here. There are 3 intervals here. I want to check one of them with the easiest possible number. Which interval is 0 in?
And
The middle. So I'm going to check f of 0. Now, this is a little bit different. This is the only one that has a singular expression with all 3 pieces. 0 minus 0 minus 24. Negative. Which means it must be what over here? How about here? Ooh, okay. We jumped through much faster there. Do you guys understand how we did that? Do you really, or are you just saying yeah? Yep, and that's okay. If we needed to check f of 9, we could, and f of -4, and you could get these values and you see they're positive. Okay, our question originally was this, which we don't have a 24 product property, so we changed it to this. Is there a place when it's negative? Is there one of these 3 intervals, or 2 or 3, where the value of f was negative? Where? Okay, so help me write it. The set of x such that x is between 2 numbers this time. It's always greater than what number? Good. Wenzel says -3. But simultaneously, it's always less than what number? Gosh, you're killing it today, David. Boom. If you don't like this, that's okay. We have an alternative. X is in the interval from -3 to 8. And we get the exact same answer. A little bit easier to write. Cool. Really debating if we want to do this other piece. I think we do. We have to. Okay, here's the deal. We are going to have a weird day tomorrow. Tomorrow, we are going to finish the section. We have one more type of problem that I want to look at, but I don't think we have enough time. So I'm going to add 3 problems to your assignment, or give you a 3-problem assignment, rather. Okay, super chill. And tomorrow's bell ringer, we will jump in, and we'll be able to finish both of them. Okay, so for tonight, and I guess hopefully in class, realistically, and I'm here to help, just to kind of remind you, that's not at all what this class is. What? We're in 6th hour. Strange. Today's the 7th. I have no idea what that was. 2.3.2 you will find again on page 81. I want you guys to do problems 32 through 36. So I guess 32, 34, and 36. Just those 3. 2.3.2, page 81, 32, 34, and 36. Okay. I've been getting a lot of homework, not necessarily from your class, but from other classes where people very clearly can get all the answers perfectly on their homework. They never miss a single question, but then in class they can't do it. I don't want to make any accusations, but it certainly looks like maybe they're getting the answers elsewhere. I have no issue if you find answers somewhere else, but here's just the good like whether you like school or not, if you want to learn the stuff and really know how to do it, which you should because you'll be more successful in future classes. If you find the answers but don't understand the work, don't just jot it down. Like, I'm super chill with people handing in late stuff this year. I'd rather you take an extra day and come and ask me so that you understand it rather than just writing down the answers. Does that seem reasonable? Cool. All right. You guys get 5 minutes. knock out the first one or two so that you'll know if you have questions for me before you peace out. Baller.